Okay, hi everyone. I'm Sam Williams. I'm one of the co-founders of Arweave, and today I'm going to talk to you about a new kind of blockchain we've developed called a BlockWeave, which allows you to scale on-chain storage to massive, massive sizes. But first, sort of a bit about why. So decentralized storage is necessary for the global computer that we've been trying to build really since the 90s, so late 90s. Since the birth of the cypherpunk movement, we've kind of wanted to have this decentralized computer that could run programs for everyone in a verifiable and redundant and reliable way. But of course, a computer is made up of many components, right? If we look at the typical von Neumann architecture, which is what you have on pretty much all of the computers that you use, like your mobile phone, your desktop, your laptop, they'll all have this basic structure, which is you've got this central processing unit that does all of your processing of actual data. And then you have a memory unit down at the bottom, which stores information for long periods of time or short periods of time, depending. So we've done pretty well with the top part, with Ethereum and other smart contract-based platforms. But what we haven't done very well at so far is this bottom part. We still don't have properly decentralized storage for our global computer, which is a major problem because it means that all of the amount of storage you can use is really just limited to what you would typically call in a computer kind of registers, or a normal computer. So that's a pretty major problem. So we've got two current approaches to the system, and I'm going to argue that both of them suck, and propose a third one. So the first approach is data storage on a literal blockchain. That is, you literally get your data, your image or whatever it is, and you put it on Ethereum or Bitcoin, where everybody has to store it if they're running a full node forever, which doesn't scale at all, and it has really broken economics as well. So when you're at block 0 in the Ethereum blockchain, the cost of data storage is almost nothing, right? But when you're at the current block height, actually you've got a couple of 100 gigabytes worth of transactions that you still have to store information about. But if you pay once to put the data into that system, if you pay once to put the your image into there, then everyone else has to maintain it forever, and they're not actually being rewarded for doing so. And further, it's not just the data storage, it's actually the bandwidth required to join the network in the first place, because everyone running a full node has to go through and download the whole thing off someone else. So that's a pretty heavy weight, and it just doesn't work. So the second, a much more common approach, is to store a hash of the data on the blockchain and then store the data elsewhere, typically in some kind of cloud storage system, so like on Amazon S3 or something of that ilk. But this is pretty bad for our system because when the data is lost, the whole system becomes unverifiable. So you stop paying for your bucket on S3, and that data is gone, and now you can't go back through the chain the whole way and verify everything that's happened, which is kind of the point of everything we're trying to do. So this obviously doesn't work very well. So blockweaves are a simple modification to the typical blockchain structure where you include a pseudo-randomly chosen recall block into the production of each new block. So essentially what that means is every time a block is mined, you take a random previous block in the network and you require that one to be looped in again to the production of the next block. And this means that you can only take part in the mining of block n+1 if you have the recall block that was chosen at block n. And you can't pre-compute what the recall block for block n+1 is going to be until block n is mined. So this means that ahead of time you have no way of computing which blocks you're going to need to store. So you have to store as many of the old blocks as you can. And this leads to a system that we call proof of access, which is a mechanism that's essentially built on top of proof of work. So proof of access means that you have to have this old block in order to mine the next block. But of course you can't work out which block is going to be ahead of time, so you have to store as many of the old blocks as you can in order to mine efficiently. Because say if you store 1/10 of the blocks, you can take part in the hashing competition for the next block 1/10 of the time. So by forcing miners to store the recall blocks, we force the network as a whole to store the data structure collectively. And we can do this And what this enables us to do is require not everyone, even if you're running a full node, to actually store all of the data in the network. And this means that we can grow the network to massive sizes because, again, not everyone is required to store all of the data. And they're rewarded proportionally to the amount of data they store. And this has another really cool property, which is that it incentivizes even storage of the blocks in the network, no matter the size of the network. So what this means is, if you're storing a block and, say, 10 other people store it, and assuming equal hashing power, then you've got a 1 in 11 chance of getting the reward for that next block, right? So that's preferable to storing a block that 100 other people in the network have stored, and then you have a 1 in 101 chance of getting the reward. So everybody is selfishly incentivized to make an even storage of the blocks at the network level, just because they're incentivized to store the blocks that no one else is storing. So the Arweave is fundamentally the first implementation of this system in the wild. We've been running a test network for 4 months. The main network launches in June. And it's a platform for permanent information storage where miners are rewarded for maintaining the data in the network. It's that the data becomes part of the proof of work, essentially. But it's also a platform for decentralized data applications. So with this system, if we think back to the von Neumann architecture, you can, it's the memory for that system, if you like. And actually, a lot of the applications we use nowadays are just memory-based applications. So Twitter, Facebook, they're really just, you create a record, you read the record, and you occasionally update the record. And that's it. That's the whole system. So you can do an awful lot of, you can build a lot of the web applications that we use every day on this system trivially. So our fundamental point for this application model is decentralized storage. Don't decentralize computation. This doesn't work for everything. Like, this is not computational money like Ethereum can do, but it does work for applications like decentralized marketplace, all sorts of things. And this is kind of interesting too because it allows you to be freer with the computation that you perform because not everyone in the network has to come to consensus about every step of the computation, which is pretty expensive. You can actually do really heavy lifting in the client sides of these applications and then do the storage of the data in a decentralized and redundant manner. So, the Arweave enables the creation of decentralized notaries, social media, mail, cloud storage, elections, and storage for other blockchain applications. With notaries, you just have, these are really all just front-end applications that do that create, read, and update process. But the critical thing is you just run application nodes around the edge of the system that are essentially portals, clients. And you can boot up as many of those applications as you like. So say you're running a notary system and you want to make sure that you're redundant. Well, you just run 10 nodes of the system. But the user experience for anyone making use of the network is exactly the same regardless of which of those 10 nodes they use because the data storage mechanism behind it all is the same. Again, with social media, Twitter, Facebook, and these sorts of things are trivial to write in this system. Mail, it's actually quite often important to be able to verify that a mail that you've sent has not been tampered with. And also you can attach financial transactions to these mails. So I can send you a contract that says, please do this piece of work for me, and I can send funds with that contract. And it's stored permanently in this system, where it will always be accessible because miners are financially incentivized to maintain it for you. And with elections, for example, it's trivial to build such a system. I made a kind of prototype in an afternoon. And what's great about it is that not only are the elections verifiable in the simple sense of you can just do it on the day that the election happened, that data will never be lost, and also that data is intertwined with all of the other elections that have ever taken place in the network. So trying to subvert one of them means that you necessarily have to subvert all of them, which you just won't be able to do. And this last one is pretty interesting. So a lot of blockchain applications obviously do use smart contracts and do need that sort of programmatic money type properties. But of course, you need storage sometimes. So we're partnering with Shelf Network, for example, thank you, who are building a decentralized auction house, basically. And of course, they need somewhere to store their listing data. So we provide that storage for them. And they just store a reference to the Arweave in their blockchain. And now they have scalable, verifiable, permanent traceability of everything that happens in their system. And it's actually pretty cheap, again, because the storage of that data offsets hashing that would otherwise have to happen in the proof of work. Yeah, and all of this is accessible through a really simple HTTP interface. So you just have a get and a put for the system. And yeah, and you can query it also, so you can tag your transactions based on the application that they're relating to or the username and that sort of thing, and then you can query it roughly like a database. But it's really, really simple to get started with. We have libraries for like 5 or 6 different programming languages now, which really just allow you to, I mean, it couldn't be simpler. It's almost like using a hard drive. We've got bounties, competitions, investment for app developers available, and you can find more details at arweave.org and read the white paper, which goes into more detail about how it all works. Thanks.